All right, hello again, everyone. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD Application and Web Development 1100 C# programming class, I've been creating a series of video presentations, mainly based off of the PowerPoint slides for the textbook we're using for the class, that being Muroc C# 8th edition. I've also done some work with a payroll program that I went over in several chapters that kind of morphed into an employee program in the last few chapters. Okay? I'm going to try again to go over Chapter 16. I did this before and it was a cluster. And some of the stuff that's in here I'm going to put off, but we are going to go over it. You have to take my word for it for now. So, Chapter 16 is on how to organize, document, and test your classes. And as you can see, we've got 3 applied objectives. Add XML documentation to your classes. Create and use a class library. And to me, that's the most important one in here. Use unit testing to test your classes and class libraries. Those are our 3 applied objectives. And we also have described 2 ways that you can code 2 or more classes into a single file. Describe the use of partial classes, describe the use of namespaces, describe the difference between file scoped and block scoped namespaces rather. Describe the benefits of creating and using a class library. Describe the advantages of unit testing, and describe the AAA or AAA pattern used commonly with unit testing. So it is permissible in C# to have more than one class in the same file. You would list one after the other. Now, why might you want to do this? Let's assume, as we did before, that let's just say that the originally, if you remember, we had a class that we called employee before we added the other ones. All right. And then we had another class that was basically our driver that ran the program. We could have put those both into the same file. Personally, unless they're both really small, I don't see the advantage to doing that. But that's me speaking. I'm not saying I'm right or wrong. I'm saying that's my personal philosophy on that. You can also nest classes where you put a class within another class. I have never done this in C#. This is something that is often done in the Java programming language. Java's got their own set of rules. I'm not going to go over any of them. We used to teach Java at Rankin Technical College, but we don't anymore. All right, so again, even though you can do this, I have never done it. All right, you can also, you may or may not have noticed, but if you bring up, let's see, what do we have here? Let's look at, not this one. Let's look at this one. This is something we're going to work on in a bit. Okay, don't worry at all about what it is, what it means, or anything. But if I go to the code, you'll notice that if I go back up to the top, what does this say? It doesn't say public class FRM song list, which is the name here. It says public partial class FRM song list. Sometimes when your class gets so big, you want to break it up into multiple files. You can do that by using partial classes. All right? I'm not going to go into it any more than that. You can look it up if you're so inclined. All right? And so there's a class that's split in 2 files, and there's a form that's split into 2 files. All right? Now, namespaces, basically, a namespace is kind of like the, for lack of better words, we'll say it's kind of like the folder that holds your program. All right? Now, again, if I go back and look at what I had just shown you, that was back here. All right, we've got song list here. Song list is the name of our project. Songs is the name here of our solution. So song list is the name of our project, but if you look, it's also the name of our namespace. That's the way that I look at a namespace. There's other things that you can do with namespaces. You can nest namespaces, all right, in different ways. You can take one namespace and bring it into another project. All right, we're going to look at some of that kind of stuff in a bit. All right, there are things that are, as it says here, that are called file scoped namespaces. Now, for that, what I'm going to do is I'm going to jump back, and I'm going to jump back into our book. All right, and as I jump back here into the book, all right, yeah, it says my session timed out, which is totally fine. Let's just bring it up again. So remember, we're in Chapter 16 here. I am finishing up now in this section. This will now be done. I've already done 17. I'm going to do 18 next. Then between tomorrow and Tuesday, I hope to get these last 4 chapters done. All right. They're not as simplistic as you might think they are. All right. I'm not going to say any more about those right now. All right. But in Chapter 16, all right. So again, we've already went through how to organize your classes. All right, but I want to get to here to 528 to talk about these scoped namespaces. So it says in the last figure, you learned how to use namespaces to group related classes. Now next, they show you how to use file scope namespaces. Notice they were introduced in C# 10.0, which means since I'm running 8 at least, we can't even use them. When you use a file scope namespace, you end the namespace declaration with a semicolon rather than a pair of braces. It says this removes the indentation required that you need for a block scope namespace. In other words, the body of the namespace is coded at the same level of indentation. This can save space and make your code easier to read and maintain. I'll leave it at that. All right. I'm kind of looking at it this way. You may or may not agree with what I'm about to say, but either way, it's fine, of course. And that is, there is so flippin' much to learn in this that I'm trying to give you a little bit of everything, but I'm trying to concentrate mostly on what I believe is the most important. And I don't feel that file scope namespaces and nested namespaces are in there. All right. Now, the next thing that's in here is they talk about XML documentation. If you've had me for another class, you may have already heard me go on and on about XML. I've actually taught a course that I developed at the college I used to work at in XML. XML is an acronym. It stands for Extensible Markup Language. And back in, I believe it was the mid to late 80s, I could be wrong, but I think it was there. So we're talking about 40 years ago. Someone decided that HTML was dead. It wasn't doing the job anymore. We need something new. So some of these people who were feeling that way came up with XML, the Extensible Markup Language. And the biggest difference between HTML, the Hypertext Markup Language, and XML, the Extensible Markup Language, is with HTML, you've got 100 or so tags. Each tag has a specific purpose, and you use them the same way. Everybody does. With XML, you make up your own tags. All right. Now that led to some problems, and it also led to a lot of different dialects of XML. There were a few hundred of them, at least at one time. There still may be. For example, there was Chem, C-H-E-M XML, that was used for chemistry. All right, there was Math XML that was used for mathematics. There was even like Chess XML for the game of chess. So there were a lot of them. All right, and sometimes that led to problems. For instance, let's say that there was a carpenter's XML. All right. And in there, you were writing some code. And you wanted to be able to use both XML and HTML. That actually happens, believe it or not. All right. And you wanted to use a table. Well, is a table, if you put a table tag in, does that mean that that table tag is for a table, like an HTML table that has a heading, that has data, etc. in it? Or is it a table like that typically is something made out of wood with 4 legs? All right. But if you want to add XML documentation to a program, you can start a line with 3 forward slashes rather, not 2, 3. XML comments put inside of your program, they're inline, so they're internal documentation, and they are gray in color, and they provide another way of providing more documentation. So you can summarize, whatever it is you're working on. You can come in before you write a method, and you can explain what the parameters are, what they represent, what the return value represents, etc. Okay? All right. A screen tip with documentation for a method. Well, yeah, you saw some of that when I wrote, for example, when we brought up the constructor for, like, for example, the commission worker class. And you saw how there was some screen tips that were put in there. So when I started to type this stuff in, the point is, when you work, this is not a dumb editor. Visual Studio is an IDE, meaning it is an integrated development environment. You can kind of look at it like it's an editor on steroids, because it does a lot of things for you. And they show some of them there. Now, I started taping yesterday, and I actually taped for about a half an hour. And then I didn't save it, because I tried doing a class library, and I had nothing but problems with it. So what we're going to try to do is we're going to try to create a class library project in Chapter 18 when we talk about using LINQ. All right? So I'm not going to go over any of this class library stuff. All right. Now the chapter ends with unit testing. And imagine, as an example, all right, let's say that there was a whole group of us who were working on this project that I've done for you earlier. In other words, the thing with the employee classes. So we had an employee class, which was an abstract class. Then we made an hourly employee class. Then we made a piece worker employee class. Then we made a commission employee class. Then we made a salaried employee class. Okay? Well, just imagine that when we're doing that when we created those, they were maybe 40, 50, 60, 100 lines each. But imagine that these were going to be thousands of lines each. We would, of course, start by creating the employee class itself. And we probably wouldn't make it abstract. We'd make sure that you could create employees. Then we'd add the hourly employee onto it, then etc. Well, the point is, what we're doing then is we are creating an application in units. And you could have different groups conceivably working on each unit. All right? When you unit test, what you're doing is you're testing the different units that make up the project. All right? You eventually have to test each unit and make sure eventually that the units that have to communicate with one another are able to do so. All right? So, why should you unit test? As it says, it helps you find problems earlier in the development cycle. Now, just as a very quick aside, I worked for 3 years at AT&T Bell Laboratories in Naperville, Illinois, as a C programmer. All right? And the last half of the year, I was actually there 3.5 years. The last half a year I was there, I was kind of getting bored. Plus, I thought that I should have gotten a promotion, and I didn't. There was a lot of reasons for that. I could piss and moan and do whatever. I'm not doing any of that. But I went into a different group. And one of the reasons I went into this different group is I was kind of told that I would probably have a better chance of getting promoted going in there. And I did. All right. Why am I telling you this? Well, the group I went into was a testing group. And we would do a lot of testing, and there was a lot of writing in there too. And my first degree, and you may or may not have heard me say this before, is in journalism. I was a reporter for a while. All right. But the reason I'm telling you this is that when I went into this testing group, it was interesting because I had to go to a bunch of meetings and stuff. And one of the things that we did was when we found a problem in the code, we tracked down when the problem got into the code and how much the problem cost to fix. All right. And as you can probably guess, the earlier in the development cycle that you find a problem, the cheaper it is to fix it. If I haven't written any code yet, but I'm just writing a document telling people what I'm going to do, and somebody says, you forgot this. And I'm like, oh, geez, I did. Well, now I can make sure when I start putting it in, all right, when I start putting that stuff in, that I've got that in there. All right. But give you a true story. And probably the man that I'm going to talk about probably isn't on this earth anymore because he was ready to retire when I knew him. And I'll give you just his first name. And honestly, it's his first name. All right. His name's Ernie, or was Ernie, or is Ernie. I don't know. All right. And Ernie was a programmer, worked for AT&T Bell Labs for a long time, did a great job, was a super good guy. I considered him to be a friend while I was there. All right. And what happened was someone in Ernie's group was working on a project. This is all true. Everything I'm telling you here is true. All right. And the projects that we worked on when I was coding, this is back in the day when you had a rotary phone, you picked it up and you got a dial tone, etc. All right. Well, one of the people working on a project in Ernie's group, it was for a different thing that Ernie was working on, but they had an error in their code. All right. And this error was bad. And what they were doing was they were going over and they were cutting over, they were putting a brand new telephony, telephone type of switch into service. And this wasn't the kind of time, again, we're talking about in the or probably early 80s, mid 80s, about 40 years ago, where you could just sit there and get online and work on it from one place and be in another place. They flew this guy out there. This was not Ernie. They flew this guy out there and he fixed the problem. It wasn't a big problem, but he fixed it. All right. They flew him back, and the next week, this guy was at a meeting. This programmer was at a meeting called in by the managers, and they was given a lot of attaboys. So actually, he was rewarded for screwing up. This is a true story that Ernie told me. So he said the next time he worked on a project, he put in a very subliminal error into his code, where most people wouldn't have noticed it, but he knew it was there. Sure enough, they cut that over, and there was an error. They flew Ernie out to the site, and he fixed it. The next week, he was brought into a manager's meeting and given a lot of attaboys. So what he told me was it paid to screw up. Now, you might look at that and say, stupid story, you just waste their time, or it was a little funny, or whatever. But the problem is, again, or the situation is, the earlier you find an error in your code, the cheaper it is to fix it. All right, you can run unit tests for a class. Each time you make changes, you can develop and test an app more quickly because you're just testing the code that was changed, and debugging becomes easier. Now, they do talk about a unit test project in here. I'm not going to do this. All right, you can take a look at it if you'd like, but I'm not, and they talk about writing asserts. I've done this kind of stuff in my career, and to me, it would be us going down a hole, and it would take a long time, and I don't know how much you'd get out of it. That's just me, and I could be wrong. All right, so what I'm going to do is I'm going to stop right now, and in just a couple minutes, and I'm only, again, 20 minutes in here, so this is short. All right, but I'm going to go over LINQ, and this will be a longer lecture, and when we're done, we're going to write either 2 or 3 LINQ programs from scratch, so you can see how these work. Now, in order to talk to you about LINQ, I'm first going to give you a short little primer on databases, which is the topic of chapters 19 through 22. But I think it will help you understand LINQ if you first have at least been exposed to some of the interworkings or whatever you want to call it, including some of the terminology of databases. So I will be back with that in just a couple minutes, and I'll see you then.